All right, this is a video on composition of functions. Okay, so the notation for this is simply this. So f0g or fog, and we call that fog of x. Okay, this is a new function where we're composing f and g, and we end up getting f of g of x. So g ends up being an input for x in f of x. Okay, so this is really what it means to compose functions notationally. Okay, so let's give an example here. So what if you have f of x equals 2x minus 3 and g of x equals x squared plus 5. Okay, so those are two functions. If I want to compose them, if I want to do f circle g or fog x, then I'm just going to write f of g of x, and I'm going to take whatever g of x is and I'm going to sub it into x for f of x. Okay, so that's going to be 2 times g of x minus 3. Okay, so f of x is the function 2x minus 3. This is the input for f of x, so I'm putting that in where the x is. Now, I'm going to replace the g of x with the actual function. So 2 times x squared minus 5 minus 3. Okay, and that equals, so we can multiply this out, 2x squared minus 10 minus 3, and that gives us a new function of 2x squared minus 13. Okay, so this new function, fog x, is this. So this is what it means to compose two functions. Okay, I could also do g circle f of x. Okay, I wonder if it gives me the same function. Okay, so it almost looks like it times, right? So f circle g looks like f times g. Now it's not. It's just f circle g. Okay, so let's see what this is. So I'm going to sub in f of x into g. So g of f of x, okay, and that's going to equal, well, g of x is this. I'm going to do f of x squared plus 5. Okay, now I'm going to take whatever f of x is and I'm going to put it in there. So 2x minus 3 squared plus 5. Okay, and when we square this, we can write 2x minus 3 times 2x minus 3. It's a perfect square, though, so when we write it out in 2 and then we FOIL it out and collect like terms, we should end up with this. So 4x squared, okay, the first one squared, plus 2 times the middle 2, so 2x times negative 3 is negative 6x. We double that, negative 12x. And then negative 3 times negative 3 is 9. Okay, so we should know how to multiply out a perfect square at this point. So, okay, so this is what came from there. Now we can collect like terms. 4x squared minus 12x plus 14. Okay, so g circle f of x is this. So we'd call this gof of x. Okay. Now, do they equal each other? No. So you cannot say that f circle g of x equals g circle f of x unless we have certain circumstances. Okay. So we could do a lot of different examples on this. But one of them would be, what if you had f of x equals square root of x and g of x equals x squared, and let's restrict x to being positive. So x is greater than or equal to 0. Okay? Now, f circle g of x equals f of g of x, and f is this, so I'm going to do square root of g of x, which equals square root, and g of x is x squared, of x squared, and that just equals x. Okay, so that's fog of x. What about gof of x? Well, okay, so I'm going to have f of x squared, because g is that, and then I'm going to sub in f of x, which is root x, and root x squared is x, and they are equal this time. But what's neat about this is they're inverses of each other. Okay? So if you take the output of this and put it into the input of this, you get x back. So if you take, for example, if you go g of 2 equals 2 squared, which gives me 4. And I take 4 and I plug it into here, square root of 4 is 2. It gets me the 2 back. Okay? So this undoes this function. So if I'm putting something into a function and then I'm putting the inverse on the outside of that, so I'm applying the inverse to the result of that, it should get me the beginning number back. Okay, so by definition of inverse. All right, so this is composition of functions. Okay, we could compose 3 functions. I could have f of x equals 2x plus 1, g of x equals sine of x, and h of x equals 2 to the x. I compose those 3 together. So f circle g circle h of x is going to be f of g of h of x. Okay, so that one. Okay. And then we just keep subbing them in. Okay, so I'm going to do, the outside is 2x plus 1, so 2 times g of h of x plus 1, okay? And g of x is sine, so I'm going to go 2 sine of h of x plus 1. And then I'm going to replace the h of x with 2 to the x. Okay, and this is a way of combining these 3 functions. Okay, so that would be this one here. And that's composition of functions.